Hi everyone, I'm Simon, project leader at Heroku, first partner in France last Monday. Today, I'm thrilled to walk you through one of our most exciting customer stories, a transformation journey we've led with Exotrail, a rising star in space tech industry. This is not just another implementation, it's a real story of industrial maturity, strategic process, redesign, and scalable architecture. All built using standard Odoo, with just the right touch of customization when needed. But first, who is Exotrail? Exotrail is a leading space logistics company based in France. They design and deliver end-to-end space mobility solution, from electric propulsion system for small satellites to in-orbit service that help deploy satellites more efficiently and sustainability. Since 2017, they've raised over 70 million, and today they support a growing base of over 30 clients across North America, Europe, and Asia. With more than 200 employees, Exotrail operates from two major hubs, Massy near Paris and Toulouse, and they've recently expanded into the US market. The project. When we joined the project, the objective was clear. Transition from a highly specific legacy setup to a clean, scalable, and standard model, especially across the manufacturing and supply chain process. We're supporting around 220 users across all departments, from production to logistics, development, procurement, finance, and deploying across 2 physical sites. This is a full-scope project, including advanced warehouse management, MRP, supply, planning, traceability, all while preserving the flexibility needed for a highly innovative environment. We can begin by the warehouse design and the receipt logistic. One of the first pain points was the receipt flow. With the creation of a new physics stock floor, we needed to rethink the whole layout. The idea was to create one single warehouse, one entry point, and to split activities across manufacturing, development, G&A, with clear separation of flow and strong rules for traceability. We've built everything around Odoo standard put array and routing system. Receipt can flow 2 or 3 steps depending on quality control requirements for production. Route and rules are configured by product and product category. And at the end of the process, items are automatically dispatched to their final location. But I will talk about that later in the presentation. We also create serial number on receipt automatically and print label directly on the receipt. So as you can see on the screen, we have only one point, and they are physically one point. And we have the routing between the manufacturing process that we want to have the major traceability and the other location for development and G&A. We apply quality check on the receipt, and we put all the parts to check on a specific location because all is not checked at the moment, and you can check it the next week or a few days later. The automatic dispatch is applied after the quality check and after the input of manufacturing. About the dispatch. The dispatch logic covers 1,000 physical storage location, and every location is linked to a parent location, and I will show you that on my demo. From there, in reception, the system handles automatic dispatching based on rules and available space in stock. We added an important constraint, 1 product per location per receipt to assure the FIFO, with the option to group cereal from the same batch in one place, useful for operational efficiency. But we didn't stop there. We also extended the standard logic to enforce location exclusivity, not just based on completed operation, but also on scheduled operations. That's a key point to ensure stock integrity, especially in fast-paced manufacturing environments. And we can go on Odoo for a little demo of that. Clearly, it's not the customer database. It's a blank database I have set up just for the demo. And for this demo, I've created on products, few products, divide on 2 categories, accessories and parts, okay. And on the inventory apps, I've created storage category, so 2 storage category, accessories and parts. And on each one, I've created the rules with the product and the maximum quantity by location with this category. And as you see as an option, for example, on the screw, I've checked the group serial number option. Because if you receive 100 screw, for example, you have 100 serial number, but you don't put one screw by location. To complete this setup, we have better rules to define when the products arrive in stock with a category. We have sub-locations to store with also a storage category. Okay, it's the base of the dispatch system. And the last part, it's the location architecture. So on the location, we can find all our final location. For example, on accessories we have 10, and on parts we have 10. Okay. This system is used because when you have 1,000 of physical location, you don't want to search the right one to put your product in receipt. You receive a batch of 500 products, and the system will tell you where you put the product on the stock. And for example, if I go to my inventory to do a manual receipt, and if I want to add a bolt, patch, and washer, I mark as to do the receipt. I will write the receipt quantity up. And now, if I go on my detailed operation, oh, it's an input, sorry. We have in 2-step receipt, obviously. So on my second step, to put in stock all my products, if I go on my detailed operation, I have all my final location for each product. And for example, for the patch, I have 10 different locations because the patch is tracked by serial number, and I don't have the option to group it. So it's don't group on final location. And for the bolt, the same. We have each final location for each bolt. We see stock, it's because I don't create enough location to handle all the receipt. With this system, we can handle a lot of receipt with many parts and a lot of final location, and assure that the automatic dispatch will put the right parts at the right location. Now, on the manufacturing. To support production, we implemented a 3-level stock model: the warehouse stock, the workshop stock, and the desk stock directly on the workstation. When a manufacturing order is launched, the system checks availability first at the work center, then on the workshop buffer, and finally in the central warehouse. With this way, we minimize the move inside the production, and we create free picking on the same manufacturing order to pick each component. The picking from the work center is validated by the operator. The picking from the workshop stock is validated by the production manager. And the picking from the stock is validated by the logistic. This way, we maximize the efficiency and we only move what's needed. The system also uses reordering rules to keep workstation and workshop stock constantly replenished. And after the manufacturing, we have a start-finish product operation, manufacturing entry time, with a quality check. And after this quality check, we decide if the parts go on the workshop stock, the warehouse stock, or if we put it on the rework stock, non-conformity stock, or if we unbuild or scrap the product. But to produce, we need the parts. And for the parts, we need to talk about supply. It's another key challenge to have the components in time, especially when the development is mandatory for each new customer. When you produce the satellite motor, each customer have his specification. So you begin by a development phase where you will build your final bill of material. But we can't wait to launch the supply. So we split the supply into 2 tracks. Generic assembly are handled via the make-to-stock using the master production schedule, the MPS, which is driven by sales order and managed weekly by planners. The MPS, we use the MPS to produce sub-assembly with a make-to-stock politic. And the final components, once the BOM is frozen, are procured via reordering rules. At the design freeze, we have our final BOM with our final assembly. And with reordering rules on the new products, we can reorder each component. To anticipate variability, we also use safety security lead time, but not in standard because we use security lead time directly by product and not general on the database. We use that because we have products with 5 days of lead time, but we also have components with 12 months of lead times. So we don't need the same security lead times on each product. To conclude, to wrap this project, reflect our philosophy at Heroku. We don't have used many specific. We have used all we can use on the standard. I have right here all the specific development we have need to do on this project. The storage category, prototype rules, and operation type. Why? Because on the standard storage category, you use only the real stock, the real stock quant on your stock, and we need to use the schedule and not the real. If we use the standard, you receive 2 parts. They will be on the same parts on the dispatch. The operation type, we have done a little development just to manage the sorting on the picking operation, to optimize the picking operation for the logistic. So when you have the picking list is optimized to do the better way to pick your components. On the production, we have done a little development to specify a stock location for the MPS, because normally it's all the stock of your database, but we have only one warehouse with many services. So we have done this development to tell this stock is for the production. And we also done a little development on the batch because it's 17 version, and the batch on the MPS, it's only on the 18. On the supply, we have the security lead time, as I already told you. the security time by product and not globally. And we also add a supplier quota on the vendor price list to ensure to order if you have a part and many suppliers, you have an engagement with your supplier for quotas, we can handle that with our development to order the same product at many vendors. And on the product and on the product, we have introduced a product request to close the product creation and have a validation system on the product creation. We also have the substitute product in BOM to have the possibility to have 1, 2, or 3 parts on the same line of BOM. And we also have a product qualification to ensure that all the products in production are ready to the production. And we don't have a development product on production. And clearly, the BOM qualification has the product to ensure that you produce only production-ready bill of material. And now, if you have a question, I'm here to answer that.
Hello. Thank you for this presentation. We have one question in the pad. So, custom lines of code reduction, what should be available in standard and isn't, in your opinion?
What should be available in standard, but it's not?
Yes.
For example, the storage category development, because the rules is pretty clear on the storage category. The category is if, I can show you directly on the storage category. Allow new product if the location is empty. So it's the standard configuration. But with this one, it's only on the real stock count and not on the schedule stock. So if you do a recipe without our development of 2 parts on the same recipe, they will go on the same location. Yeah. But we needed clearly to have it by product because you don't have the same security lead time if you have a product with 5 days of lead time or 12 months, and we have the security lead time by product for purchase, manufacturing, and sales.
Okay, thank you. That's the only question. So thank you very much. Oh, there is a question. I'll come to you. Wait. Do you hear me?
Yeah, sure. I hear you. There are a lot of people, but I hear you.
Okay, thank you. So thank you for the presentation, Simon. I have 2 questions. My first question is, so is it an Odoo SH project?
No.
Okay, how did you manage to implement that way without Odoo SH then on premise?
Yeah, we don't have assure the hébergement, the hosting. Thank you. We don't ensure the hosting, but it's an on-premise project with a big security on it. So you can connect it if you don't have signed many papers and all of that. But to do development on this environment, you work on your local computer on blank database, and after it's on-premise, but you have one pre-prod environment and one test environment. So you have access to a GitLab, you commit on it, you build your test environment, it works, you push it on the pre-prod environment, it works, and after you put it in production. Okay. Like Odoo SH, but more complicated.
Yeah, I can imagine. My second question is about, like, here you said, so it's custom project at the end of the day. So what is the percentage of standard and custom that you have done in this project?
We have done very little development.
Those ones are specific?
Yeah, it's just that.
Okay, and what is the percentage of the project it took?
When I arrived on the project is very for the manufacturing and for also this part to is not the same. Yeah, here.
Okay.
Because when I arrive, it's clearly a big specific project with a complete module database. Okay, and we have reduced this one for scalability and to ensure the migration.
Okay.
Now I think we are at 90% standard.
Okay. And in terms of time, is it the same? Does it take 10% of the time to do those developments, or it takes way much more time?
No, you have 90% of standard, but you have 40% of your time to the specific.
Okay, thank you, Simon.
Yeah, just have a last question maybe. Does Heroku has other customers active in the same sector?
Not yet. No, not in the same sector, but on manufacturing and industrial manufacturing, yes.
Because I think it's a pretty good reference, and it could be interesting to advertise it a little bit more.
Yeah, it's a cool reference. But we have other projects in manufacturing and industrial manufacturing. Maybe next year, and not on the Saturday, I will do another success story.
Thank you, Simon.